Yo, what's up, y'all? So today we're doing quadratics and align systems. Yeah, let's go ahead and get to it. Alright, so this is a review from Algebra 1. These are systems of linear equations. So there's two ways to solve these. You can either do substitution or elimination. So let's go ahead and do elimination first. So what you do with elimination, and I'm going to do this work in red, is you have to kind of get both of these in standard form. So what I'm actually going to do is I'm going to subtract x from both sides on the second one. So I'm going to rewrite the first one here. And then I'll have negative x plus y equals negative 1. And now what you have to do is you have to eliminate one of the variables by either adding or subtracting. So I'm actually going to subtract the second one from the first one. So 2x minus x, well, that is 3x. 2x minus negative x. Y minus y is 0. And then here I get 5 minus negative 1. Well, that is 6. Solve for x, you get x equals 2. And now to get the other variable, you plug x back into one of these. So let's go ahead and do 2 times x, which is 2, plus y equals 5. 2 times 2 is 4, plus y equals 5. Y is equal to 1. So your answer is 2, 1. Alright, so the other way to do this is substitution. So that's solving for one of the variables and then substituting that into the other equation. So in this case, it's really nice. Y is already solved for. So I can plug in x minus 1 into the first equation. So let's see what that looks like. So we have 2x plus y equals 5, and then y equals x minus 1. Now I'm going to substitute x minus 1 into y for the second from the first equation. So 2x plus x minus 1 equals 5. Now you add all this up together, you get 3x minus 1 equals 5. So then you add 1, 3x equals 6, and x equals 2. Plug it back into the first equation. So 2 times x, or substitute 2, plus y equals 5. Now 4 plus y equals 5, and y equals 1. So we get the same thing, 2, 1 for our solution. So whenever we have a quadratic and a linear equation, we're not really going to use elimination. Instead, we are going to use substitution. And let me show you why. It's because here it is an example. So whenever we have a quadratic and a linear system, a lot of times things will already be solved for y. But even if it isn't, just go ahead and use substitution. Trust me, it's a lot easier just because we have this pesky x squared term. And since only one of them will have the x squared term, it's just going to get kind of like weird. Just go ahead and do substitution. Trust me, it's just easier. So let's see, substitution. So I'm going to substitute 3x plus 4 for y in the second equation. So we'll have 3x plus 4 equals x squared. Now I need to solve for x. So I'm going to have x squared minus 3x minus 4 equals 0. So I subtracted 3x and subtracted 4 from both sides. And now I'm going to factor. So x minus 4 times x plus 1 equals 0. Solve for x and you get x equals 4 and negative 1. So set each term equal to 0. Now I have to plug each one of these solutions back into one of the functions. So I'm going to plug it into the second one. So let's see, for 4, we have y is equal to 4 squared. So that is y is equal to 16. So one of the solutions is 4, 16. Now I'm going to plug in negative 1. So we have negative 1, and we have y is equal to negative 1 squared. And that is equal to 1. So another one of the solutions is negative 1, 1. And I'm going to go ahead and pull this up on Desmos so you can see that this is actually true. Alright, so I have here, I have it on Desmos. I have y equals x squared. It's in red, and then y equals 3x plus 4. It's in blue. And as you can see, the solutions are going to be the intersection points. So I've already highlighted them. Here's -1, 1, and here's 4, 16. So that just shows you that it works graphically as well if you want to graph it and find the solutions that way. So let's go ahead and go back to this. And I'm going to go ahead and do 2 more examples, and that's going to be it for the video. All right, so here's another example. I'm just going to do the same exact thing, substitute the linear equation, substitute 6x minus 1 for y, and then solve. So let's see what happens. So we get 6x minus 1 equals 2x plus 3, 2x squared plus 3. And I move everything over, so 2x squared minus 6x plus 4 equals 0. I'm going to divide both sides by 2, so x squared minus 3x plus 2 equals 0. And then I get x minus 2 and then x minus 1. So x is equal to 2 and 1. Now we're going to do the same thing. So I'm going to plug this back into one of these equations to get the y coordinate. So let's do 1 first. So we get 6 times 1 minus 1 equals y, and that's equal to 5. So one of the coordinates is 1, 5. Plug in 2, and we get y is equal to 6 times 2 minus 1, and that's equal to 11. So the other one is 2, 11. So your 2 solutions are 1, 5 and 2, 11, and those are your answers. All right, so last example, and that's going to be it for the video. So here's another one. It looks kind of weird, but let's see what happens. So I'm going to go ahead and substitute x minus 20 in for y. So we have x minus 20 equals negative x squared minus 20x plus 2. And I'm going to move everything over to the left. So x squared plus 21x minus 22 equals 0. So this will be x plus 22 times x minus 1 equals 0. So x is equal to negative 22 and 1. And now I get to plug these back in to find the y coordinate. So let's do negative 22 first. So we have y is equal to negative 22 minus 20, and that's equal to negative 42. So that's 1. I'm going to write this over here. So negative 22, 42. And then the other one, I plug in 1. So this will be y is equal to 1 minus 20, and this will be negative 19. So the other coordinate is 1, negative 19. So those are my 2 answers. Hopefully this makes sense. If it doesn't, let me know, and I'll get back to you. So thank you.